Okay, today we're going to continue with Module 3, Lesson 2. We left off last week talking about positive and negative numbers, and we're going to continue that this week. So we did this same problem last week. We started it and we didn't get to finish it, so I would like to spend some time working on it today. I'm going to start by reading the top again. Temperature is commonly measured in one of two scales, Celsius or Fahrenheit. On this scale, you can see that Fahrenheit is on the left-hand side right here, and Celsius is right here on the right-hand side. So the scale is on both sides. If you notice, the numbers are a little different. In the United States, the Fahrenheit system continues to be the accepted standard for non-scientific use. I mentioned that last week, that this is the one that we tend to go with whenever we're talking about temperature. Temperature outside, temperature in your body. When you take a temperature, either with a strip on your forehead, or the nurses run something along your forehead, or in some cases you actually put a thermometer in your mouth. That thermometer is something very similar to this, and your temperature, your internal temperature, is gauged using this type of format, this system. The outside temperature, the air that we're feeling when it's warm versus when it's cold, that is also based on Fahrenheit. Okay. Note that, however, all other countries have adopted Celsius as the primary scale in use. So when you're reading about science information, stuff with Mrs. Beauclair, you may hear the word Celsius when they're talking about it, or if you're listening to something in the global world. The thermometer here shows both scales, so you get an idea of what number-wise what it looks like. The conversion of it is interesting, but we're not going to worry about the conversion of it at this moment. That's not what today's lesson is about. So last week we already talked about this. The boiling point of water is 100 degrees Celsius. Where is 100 degrees Celsius located on the thermometer on the right? Last week I talked about the fact that it's actually not there on Celsius. Celsius would be this side. And if you look, the highest number in Celsius is 50 degrees. So where it says the boiling point of water, where is 100 degrees, located on a thermometer, the answer that we chose last week was that it's not shown on a thermometer. And if we wanted it to show, we would have to increase the thermometer height. We'd have to actually make a thermometer go higher to do the 100. So that's what we did last week. Okay, so I wrote it in for us. It is not shown because the greatest temperature shown is 50 degrees Celsius. And I also erased some of the other stuff so we can continue to work on it. Okay, so you'll probably see some questions start popping up now in this video that you'll be able to answer yourself. On a vertical number line, describe the position of the integer that represents 100 degrees Celsius. So let's try it this way. If we had a vertical number line, and we had the 0 degrees here, actually, or 0 degrees can be listed somewhere else for Celsius, where do you think the 100 degrees would be? Would it be below the 0 or above the 0? So the 100 degrees would have to be somewhere above the 0, going up. And it would be a positive number because we're talking about an integer here. Okay, so that's what I've written down here for us. The integer is 100, and it will be located 100 units above 0 on the Celsius side of the scale. The Celsius side being on this side here. All right. Nicely done now. So now we need to look at which temperature is an integer. Write each temperature, as an integer. So the first one talks about the temperature shown on the thermostat in degrees Fahrenheit. That refers to where the red refers to what the temperature is right now. So based on that, going all the way up here, where does it end? So the integer of that would be 100. And it would be a positive 100 because all of the positive numbers are up here and the negative numbers are negative below 0. Okay, the next one says, what is the temperature shown on the thermometer in degrees Celsius? So the same spot, but not on this side. Instead, we're looking on this side. And that's where we left off last week. And we said if you counted all the lines in between, it might be hard to see on the video, but there are actually lines that are going in increments of 2. So if you did 2 for each line, it would be 32, 34, 36, and this line is actually, you can't see it that well with this there, is actually at about 38. And so that's what we said we were going to put for here. For an integer, it would be 38. And as we talked about last week, these are both positive numbers, but we don't write the positive sign. For positive numbers, we don't write the positive sign unless we absolutely have to. We just write the regular number, and that's acceptable for a positive sign. Okay, so number 3 says the freezing point of water in degrees Celsius. So if you look at the picture, it shows you right here, the freezing point of water in degrees Celsius is, and it points directly to the 0. And so in 0, there isn't a positive or negative. 0 is kind of neutral. If you say 0 positive or negative, you just generally say 0 is kind of like neutral. If someone says write a positive 0, then we just write a 0. If someone says write a negative 0, there isn't such a thing, we just write a 0. So what we would say is that, so for example, last week we learned the opposite of 0 is 0. There's no positive or negative. Okay, moving on. If someone tells you your body temperature is 98.6 degrees, which scale is being used? So looking over here, remember you have Fahrenheit on one side and Celsius on the other, and they say your body temperature, so you go to the nurse, and the nurse takes your temperature and says you are 98.6 degrees. Which scale is being used? Fahrenheit or Celsius? Okay, so if you thought about it, there are a few clues I gave you already. First off, in the United States, we use Fahrenheit. But it didn't tell us that this was the United States. So the other clue that you really needed to know was this one. The boiling point of water is 100 degrees Celsius. So let's think about water boiling on the stove. If water is boiling on the stove, it's really hot. Hopefully you've never put your finger in boiling water, because if you did, you will have burned yourself. So let's consider this. Would the inside of your body be that hot that you could burn yourself to the point you'd have to go to the hospital? That doesn't make sense. I know sometimes when you get really warm, your parent will put their hand on your forehead and they'll say, wow, you're burning up. And it may feel really hot to them when they put their hand on your head, but they can still put their hand on your head, on your forehead, and it won't blister or send them to the hospital. So you don't get quite that hot. So for those two reasons, your answer should be it's 98.6 degrees Fahrenheit. When we're talking about the temperature of an adult, it would be right around here. And usually 98.6 degrees is acceptable. That usually means you're fine. That's where your body is normally, the internal temperature. So if we were using Celsius and if it was that hot, you would probably not be alive. So in this case, we will put Fahrenheit. Okay, I added a little explanation. So since the water boils at 100 degrees Celsius, they must be using the Fahrenheit scale. So E says, does the temperature 0 degrees mean the same thing on both sides? Does the temperature 0 degrees mean the same thing on both sides? Okay, hopefully you looked at it and you could see that on the left-hand side, that on the right-hand side, 0 degrees is right about here. Is right here. Let's make that a little thinner. And if you went straight across, then that is not where the 0 degrees is on the Fahrenheit side. The 0 degrees on the Fahrenheit side is actually over here, down here. So 0 does not mean the same. The temperature is the same. So whatever they're taking the temperature of, it's still the same. How we read it is what's different. On the right-hand side, we read this temperature up top here as 38 degrees. On the right-hand side, on the right-hand side, we read it as 38 degrees. On the left-hand side, we read it as 100 degrees Fahrenheit. So the 0 on the right-hand side refers to the freezing point in Celsius. However, that same freezing point on the left-hand side is actually 32 degrees. You probably can't see it that well, but if we went straight across here, it would not be 30, it would be 32. I just can't draw a straight line. And these lines here are very tiny. So it would be 32 degrees Fahrenheit, and that's what the degrees would be in Fahrenheit. So the 0 is not the same. The 0 down here in Fahrenheit, our 0, is negative, because you see the negative sign, negative 10, 12. Now we determined that on the right-hand side it's increments of 2, so it would be 10, negative 12, negative 14, negative 16, negative 18. So on the Celsius side, the Fahrenheit 0 is actually negative 18 Celsius. So do the temperatures 0 mean the same thing on both sides? No, they don't. No, so 0 degrees Celsius is 32 degrees. Notice it's a positive on the Fahrenheit side. And 0 degrees Fahrenheit, that should be a 0, sorry. Fahrenheit is about negative 18 degrees on the Celsius side. That's what we talked about up here. Here's what the 0 degrees Fahrenheit is. Okay? All right, let's move on. Let's see how you do now. Before I give the answer, I'm going to have you go ahead on EdPuzzle and answer the question and see how you do. Okay, so for the first part, all you have to do is what we did earlier last week and answer by putting it as an integer. So, express each situation as an integer in the space provided. So it's either going to be a positive, which won't have a sign in front of it, or the negative sign. So, let's talk about this. A gain of 56 points in a game. A gain, which means you move forward, of 56 points in a game. Is it a positive 56 or a negative 56? Well, hopefully you remembered that it is a positive 56. Very good. How about a fee charged of $2? Is it a positive 2 or a negative 2? Remember, we're not putting the money sign when we're talking about it being an integer. So is it a positive 2 or a negative 2? Right. If it's a charge, it is a negative 2. Well, I hope you got it right. Okay, C says a temperature of 32 degrees below 0. Now, in this case, it doesn't matter if it's Fahrenheit or Celsius. A temperature of 32 degrees below 0. Okay, so the word below was the key word here. Whether it was in Celsius or in Fahrenheit, it was below the 0. And so it had to be down here, and both below zeros are negative numbers. So this one needed to be a negative 32. All right, let's hope you did well on that one. Okay, how about the next one? A 56-yard loss in a football game. Now I know my two football players, Jalen and Joel, would know this one. A 56-yard loss in a football game. Okay, if you're losing, if you lost something in a football game, you're usually trying to advance towards your goal, trying to go that way, unless your goal is the other way. But let's say your team's going this way. If you lose yards, then you go that way, and the loss of a yard is a negative, so it's negative 56. Okay? Next one. The freezing point of water in degrees Celsius. Freezing point of water in degrees Celsius. You can go back if you need to. You can move the cursor back even further in EdPuzzle at this point if you need to. Okay, the freezing point of water in degrees Celsius is just 0 for Celsius. If you remember, that would be right here. All right, the next one. A $12,500 deposit. Sure, a $12,500 deposit is positive. So far, so good. No problems here. You guys are doing a great job. Okay, for problems 2 through 5, we're going to use the thermometer to the right here, and we're going to, this is where it gets really wonky. Each sentence is stated incorrectly. So right there, it is incorrect. We need to rewrite the sentence to correctly describe each situation. And I'll probably give you some more work on this part because this is a fun thing to do. Okay, so the temperature is 10 degrees Fahrenheit below 0. What is wrong with that sentence? Well, we can say something is is negative 10 degrees Fahrenheit. That makes sense. We've heard that before. It's negative 10 degrees outside, right? We can also say it's so many degrees below 0, but we tend to not say the negative number when we say below 0. So there are two ways we could have written 2a. I'm going to write it over here so that you can see. Okay, so the first way you can write it is the temperature is negative 10 degrees Fahrenheit, and that's my degree sign above that. I had to draw it in. So that is one way you can do it. The temperature is negative 10 degrees Fahrenheit. If you can't draw the degree sign because we're working on a computer, you can write the word out, just so you know. The bottom one is the same thing because we could also write it as the temperature is 10 degrees below 0. Notice at the bottom one, we don't use, it's almost like we use the expanded version of it. When we're writing it on the one below, we're kind of expanding out, we're describing the situation. The temperature is, and we're telling you where it would be located on the number line. So the temperature is 10 degrees below 0. Above, we're writing it as if you would say it as if you're the weatherman. The temperature outside is negative 10 degrees. Both of those would work. What they have in A will not work. Okay, so knowing that, let's look at the second one. Let's see if you can do this. The temperature is negative 22 degrees Celsius below 0. Let's see if you can write it with either way. You can write both, or you can just write the way we did it on the top way, or the way we did it on the bottom. This way or this way. Go ahead and you write it correctly. One or both those ways. Okay, here's how you can write it. I mentioned that it's hard sometimes to get the degree signed. On mine, I can just draw the degree in here. But you may not have been able to do that, so you may have been a little frustrated, and I apologize. The temperature is negative 22 degrees Celsius is one way of writing it. And if you can't get the temperature sign, the degree sign, in there, you can write the word degrees out like this and then just put one letter next to it. The other way you can say it is just by saying the temperature is 22 degrees below 0 Celsius. Those are both acceptable ways. What they wrote here, that is not acceptable. Okay, so the next part you really can't do, so I'm going to do it for you. Mark the integer on a thermometer that corresponds to the temperature given. Corresponds is when it matches. That's all that word means, is matches. So 70 degrees Fahrenheit, if you look on here, that would be right here. Okay. 12 degrees Celsius, though, it would start at 0 and then go up to here. That's 12 degrees Celsius. So the first one is A. The second one is B. The next one is 110 degrees Fahrenheit. Well, you know that has to be on the left-hand side. In fact, let me change this over here. Let's make B the green one. Okay. C, I'll make that one be the red one. 110 degrees Fahrenheit would be right here. C, and that's on the Fahrenheit side. Negative 4 degrees Celsius, I have to go all the way down to the negative side. And remember that it's in increments of 2. So if you remember, that would be right here. And we can write that as C that way. Okay, so that's a nice easy one. Number 4 says the boiling point of water is 212 degrees Fahrenheit. Can this thermometer be used to record the temperature of a boiling pot of water for Fahrenheit? Can we use this thermometer? So the correct answer to this is no, it cannot, because if you look on the side of the Fahrenheit, the highest that it can go on this thermometer is 120 degrees. Now, it can be recorded. It just cannot be recorded on this thermometer. That's important because you can have a thermometer that's pretty big. When you get higher up into your other science classes, maybe beyond high school, even in college, you will find that they have thermometers that are pretty big. And they might be able to record something as high as 212 degrees Fahrenheit. But this thermometer cannot, and they asked, can this thermometer be used? So that's important to clarify that, okay? All right, 5 says that Kaylan shaded the thermometer to represent a temperature of 20 degrees below 0 Celsius, as shown in the diagram. That's what they see right there, that blue on the bottom there. Is she correct? Is that at 20 degrees below Celsius? Below 0, sorry, on Celsius. And if not, tell me why she's not. And then if you can, how would you fix this? So this is a real short answer question. We'll read it again. Kaylan, shaded the thermometer to represent a temperature of 20 degrees below 0 Celsius, as shown in the diagram. That would be this part right here. Okay? So she shaded it. She said that it is 20 degrees below 0 on the Celsius side. Is that a true statement? If it's not a true statement, if it's not correct, tell me why, and then how would you fix it? If you were trying to be the teacher and explain to Kaylan if she's right or wrong. Okay, so you may not have written this exact wording here, and as long as you wrote something that makes sense, you will get it correct. So she is incorrect because she shaded a temperature of negative 20 degrees Fahrenheit. I would tell her to fix this by making a line segment at negative 20 degrees Celsius and shade up to that line. And if you look, that would have been right here. So really, that's where she needed to shade it up to, was up to here. What she did was she looked at the Fahrenheit side and shaded it only to there. But she needed to go as high as the Celsius. That's negative 20 degrees Celsius. Okay, and that is all we're doing for today. You don't have any other work to do except for this. So nice job. We went a little bit over. You have time? No, you probably would have gotten hit the 30 minutes by now with answering all the questions. So we'll see you for lesson 3.